Question 8. Show that the line with equation y equals 3x minus 5 is tangent to the circle with equation x squared plus y squared equals plus 2x minus 4y minus 5 equals 0. And find the coordinates of the point of contact. Okay, so what you're going to have to do here is substitute in this value for y into this equation for the circle. And once we've done that, we'll be able to investigate the behavior, and then we'll be able to see if there's only one point of contact. So we're looking to prove that it's a tangent. So, we'll either be using the discriminant here, or there'll be something like a double root. So what we're going to first do is write out our two equations. This is quite a lot of working, but just try to follow along, and I'll try not to make any mistakes. So, and x squared plus y squared plus 2x minus 4y minus 5 equals 0. Okay, so this then becomes x squared plus 3x minus 5 squared plus 2x minus 4 3x minus 5. 3x minus 5 minus 5 0. Okay, so x squared, so okay, plus square the first term, which is 9x squared, times the two terms together, so 3 times 5 is negative 15, and then double them, so that's negative 30x. And then square the last term, that's plus 25, and then again 2x, okay, then minus 4 times 3 is going to be 3x is going to be 12x, then minus 4 times minus 5 is going to be plus 20, and this is going to be minus 5 equals 0. Alright, now this is just a case of tidying it up. So all the x squared terms, and then I'm going to give it a different color, all the x terms, okay, and then just all the terms with no x. Okay, just so I can visualize. So x squared plus 9x, which is 10x squared, and then I'm going to do 30 minus 30x, and then you have plus 2x. I don't know why that's gone there. That should be a plus. That should be a plus 2x. So 2x. Okay, this is going to be minus 30 minus 40x. X 25 minus 5 plus 20 is going to be 40. Okay, equals 0. Now this can all be divided by 10. So this becomes x squared minus 4x plus 4 equals 0. Okay, so what we need to do here is, looking at this, can we show that this is going to be the tangent? So you could use the discriminant, but for this example it's going to be more straightforward just to factorize it, and you'll see why in a second. So what we're going to do is try and find the roots of this equation. So 4, so it multiplies to 4 and adds up to 4, well 2, so x, well minus 4 and plus 4, so yeah, multiplies together to make so 2 and 2 and x and minus 2. So those are your two roots there. So x minus 2 squared equals 0. So when you've got this x minus 2 and this squared term, it means it's a double root, or you could say it means there's only one root. So you want to have some kind of statement here. So one root, therefore at a tangent. Therefore it's at a tangent and occurs at x equals 2. Okay, but that's not all the question asks for. The question also asks for find the coordinates of the point of intersection. This means we need to use this x equals 2 and figure out what our y point is. So we could, so what we need to do is we've already got a formula for y, so y equals 3x minus 5. And now we're going to put in our 2, so 3 times 2 minus 5, so 6 minus 5 equals 1. So you'd write something like the point of contact is 2, 1. Brilliant. Okay. So where are your marks in here? Well, your first mark is for substituting in for y, so here. And then your second mark is for factorizing the discriminant, which is here. And then your third mark is for interpreting the result and proving tangency. So yeah, 1 root, there you are. And then your last mark here is for finding the coordinate here. So it's that 1, 2, 3, 4, 5. So 5 out of 5.